Hello and welcome to this presentation. We will introduce some machine learning models applied to natural language processing, and especially we'll try to discuss attention-based models. Attention was an innovation that raised huge interest and earned wide adoption in NLP and other areas of machine learning. We will try to build everything from the ground up, so no need to be a data scientist or a computer programmer or a machine learning engineer, nothing like that. We'll think that these subjects can be interesting for anybody, so we will try to tackle them at a beginner level. Let's try to put the concepts that we will be discussing on a kind of map. We are within machine learning space, and in particular, we're talking about neural networks applied to natural language processing. We think that this subject has a lot of interesting features at the moment for the speed of evolution and for the elegance and efficacy of some of the discoveries, some of the recent discoveries. There is a mixture of math and language, which is fascinating. And also we see everyday impacts on everyday life, like automatic translation, personal assistants, chatbots, question answering systems, and so on. So within NLP, this presentation is an introductory one. We will try to introduce some basic concepts, and we will talk about neural networks, recurrent neural networks, embeddings, encoder-decoder architecture, and we will try to build piece by piece a machine translation model which is based on attention. So attention can be seen as the ultimate target goal of this presentation. The model that we take as reference for the concepts that we will be discussing is taken from this paper, which is the original paper in which attention was introduced. It's considered a landmark paper, and after this paper, the concept of attention had a lot of impact within NLP and also in other areas of machine learning. About where this work is coming from, it all started with the idea of producing something to consolidate personal notes and help studying in a systematic way. And the true reason for this is mostly studying in the spare time for the pleasure of it, for the interest in the subjects, and so to basically have fun. What we try to do is that there is the attempt to cover breakthrough ideas and to do it in a way that is open to beginner level listener. So we will not give anything as known, as given, as obvious, and will be the attempt to explain and dig into every basic concept. and shielding as much as possible from math, but relying as much as we can on intuition. This is the spicy menu that we will try to serve if we manage. We will try to start from the concepts of sequences, problems that are based on data that are organized in repetitions, in multiple occurrences of some data structure. Then we will depict in general the encoder-decoder architecture, which is often used to solve problems that must read a sequence and produce a new sequence based on the input. Then we will introduce two concepts that are necessary for the rest of the presentation, and they are recurrent networks and embeddings. After discussing a little bit what are the limitations of recurrent networks and encoder-decoder, we will introduce the main concept that we are aiming at, which is attention. After discussing attention, we will say something about the achievement and the performance that these models achieved, and we will finish with some final concepts and comments as a wrap-up. Let's start then talking about sequences. The best thing is probably giving some examples of what sequence problems are. In speech recognition, you are given an audio and you must translate the speech in a written text. So the input is the audio as a sequence of sample waveforms, and you asked to produce a string of words or characters. In music generation, the output is a sequence of notes, and the input can be an empty set or maybe just a single choice about what kind of music you want to produce. Sequences are how DNA is arranged. So for DNA sequence analysis, we have a string and a series of repeated data. Especially in machine translation, you are giving a sentence, which is a sequence of words, and you are asked to produce the translation in a different language. There are many other problems, and especially all the problems that deal with language are based on sequences. If you want to produce a question answering system, you have to take a question, a phrase as input, and produce a phrase as answer. If you want to build a named entity recognition system, you have to analyze text. If you want to build a chatbot, you have to analyze the customer text, and you have to produce the right answers for it. We can try to introduce the specifics of sequences and models that deal with sequences, even if we haven't discussed about what machine learning models and neural networks are. But we have the intuition that a machine learning model or algorithm is something that we can give some input data and we get a decision or an output which is an answer like we see here in the example on the upper right. We can say we have a system that is judging credit card applications. So we can provide an input like the age, the salary, education, and so on about the customer. And the network that we see as a black box tells us the decision, which is a yes or no. Then we can use the same algorithm for another customer and another and another, and we use the neural network in one shot. We provide the input, we get the output, and then we can use the same algorithm again for the next user. We can say that the system is stateless. It doesn't remember anything between one invocation and the next. This is not enough if we want to deal with sequences. So what we will talking about are so-called recurrent neural networks that have something more with respect to the neural network that we just talked about, because they are able to work over a sequence of data and to digest these input or produce some output symbol by symbol. And for each symbol that we process, there is a separate invocation. And of course, between one invocation and the next, the system remembers the state, remembers what has been done before, because of course all data in the sequence are related each other. So in the picture below, we see a model which is a little white box, and we must pay attention to the fact that it is the same model but is drawn many times because we are seeing it through a sequence of time steps. So in the we see that this model is digesting a sequence which is A, B, C in the first 3 steps, and then is producing a sequence W, X, Y, Z, end of sequence in the next steps. So the difference of recurrent neural networks is the little right-bound arrow that link one box to another. This kind of network is stateful and remembers what has happened before. So when we produce the Z, the state of the model depends on what happened in the step before when we produced the Y, and the step before, and the step before, until the first step when we received an A as input. Having a rough idea of what's the difference between a standard neural network, or we could say a vanilla neural network, and a recurrent neural network, let's see the basics of what is an encoder-decoder architecture. As promised, we will try to introduce every concept from the basics very slowly. So, an encoder-decoder architecture is a machine learning model which is based on two neural networks. And we see in the picture at the bottom, the two neural networks are called encoder and decoder. And they are linked by a vector of numbers in between. So what happens in this kind of models is that the encoder is reading an input sequence, most of the time a sequence of words. I am a student in this example, and somehow produce an encoded representation of this text. And the only interface with the decoder is this vector. After this vector is produced, the decoder takes this string of numbers as input, and it is able to produce another string of words, sequence of words. These kind of models are used for any kind of sequence transduction models. So it could be a question answering system or any kind of model that is able to map from a sequence to another sequence. In this case, we see the example that we will dealing with in the rest of the presentation, which is a machine translation model. If the picture of an encoder-decoder architecture that we saw before was very simple and clear, we will try now to dig into these kind of models, and we will now work with a much more detailed picture, and that's where things start to becoming a little bit messy. But we'll try to see everything bit by bit and try to explain what is going on. So, as we saw before, we have this model which is made of two separate parts, and as we saw before, these two parts communicate only through a single vector of numbers which stands in between and that we see here in the middle. Both the two parts are made of a recurrent neural network. So on this side, we have one network, which is the encoder network, which is here drawn 4 times, but we know at every step it is the same network that we are using. And this network is receiving as input 4 symbols in 4 time steps. And the symbols are how, are, you, question mark. Then, on the other side, after the vector in between is produced, we have another different recurrent neural network, which is somehow specialized in the coding. And this network is, in first step, is producing an answer. So it's producing I am fine. End of sequence. Okay, and we have here a different recurrent neural network, which is invoked 4 times, and which is not surprisingly passing the state here from one step to the next. So the main ingredient, the main component of this menu is recurrent neural networks. So to understand a little bit better what's going on, we will try to say something about what recurrent neural networks are. Let's move on to recurrent networks then.